first, we turn to the search for a treatment for Ebola. West Africa is still dealing with the aftermath of the worst outbreak of the disease in recorded history. Last week, Liberia reported a handful of new cases, just months after the World Health Organization said the country was free of the disease. And this weekend, not one but two panels said the WHO needs to substantially reform and change the way it deals with international health crises. Special correspondent Mary Jo Brooks has a report on the hunt to finally stop the virus.
It looks like an ordinary greenhouse filled with plants basking under lights. But at this facility, just outside Owensboro, Kentucky, the plants themselves have become a labor force, working around the clock to manufacture a cure for Ebola.
These plants are 27 days old.
3 days earlier, these plants were injected with the genetic blueprint for one of 3 antibodies used in the experimental drug Z-MAP. Hugh Hayden of Kentucky Bioprocessing explains how it works.
The plant recognizes that gene, and its machinery turns on, and it starts to manufacture that protein for us. And it's really that simple. It becomes a little bitty factory.
Z-MAP was still in the developmental stage when Ebola first broke out in West Africa in March of 2014. The disease has since claimed more than 10,000 victims. But a handful of people were successfully treated with Z-MAP, including Dr. Kent Brantley.
Today is a miraculous day. I'm thrilled to be alive, to be well, and to be reunited with my family.
Since then, the drug has been undergoing clinical trials in West Africa, and the FDA has granted it fast-track approval status. Larry Zeitlin and Kevin Whaley are the scientists from San Diego who developed the Z-MAP antibodies, which were designed to quickly attack the Ebola virus.
In a vaccine, you give a person a protein that stimulates your own body to make antibodies. In this case, we're giving antibodies directly to you, so your body doesn't have to make them.
And unlike a vaccine, where it takes you weeks to months to build up protective immunity, as soon as the antibody is provided to the patient, they're protected against that disease.
Speed is the name of the game in fighting infectious disease, and it is the reason that Whaley and Zeitlin decided to manufacture their drug using plants rather than the traditional animal protein method. They chose an Australian relative of the American tobacco plant in a process that is quick and relatively simple. Just 3 weeks after the seeds go into the soil, the plants are mature enough to be dipped into a liquid which contains proteins to be replicated. The plants grow those proteins for another week and then are harvested and chopped up. The resulting green liquid is filtered and tested, and by day 40, it's ready to be shipped out.
It's a very fast system. If it's faster, it costs a little bit less on the front end particularly. It gives you a lot of flexibility in terms of developing a product. You get your protein, you look at your protein, is it what you wanted? If it doesn't have the exact characteristics that you want, you do it again. You re-engineer it, do it again until you get exactly where you want to be.
This system of biofarming could be useful for a number of drug therapies that must ramp up production quickly. The Canadian company Medicago uses tobacco plants to manufacture flu vaccine, which needs to change seasonally. At its large greenhouse in Raleigh-Durham, North Carolina, workers and robots tend to the growing plants.
They produce the vaccine over about a week.
So it's a very quick, efficient process.
It's very quick, very efficient, very adaptable.
Michael Shunk is the vice president of operations.
This plant technology can respond in about half the time of the traditional flu manufacturing technologies. So that's what started us into the flu, and we've just continued to grow with that.
Medicago is in the final stage of clinical trials to receive FDA approval for its flu vaccine. Once granted, the company says it'll be able to make 30 million doses a year. It has also begun producing an Ebola drug similar to Z-MAP. Both Medicago and Kentucky Bioprocessing received Defense Department money to develop their biopharmaceuticals. The hope is that the technology could be used to quickly counter a pandemic or bioterrorism attack.
This facility is about 27,000 square feet.
But Michael Shunk says the technology holds promise for all kinds of drugs. He's especially optimistic that developing nations will use this method to manufacture vaccines on their own soil, since the cost of building the facilities is much less than traditional drug factories.
This is not a very complicated technology. It's certainly transportable. Every country has greenhouses, so every country has the potential to have a facility that can be used to produce vaccines that maybe are more of concern to that particular country.
Shunk and other biofarming proponents predict that soon drugs to treat herpes, HIV, MRSA, and other infectious diseases will routinely be grown in plants. Of course, the irony of using a version of tobacco to save lives is not lost on anyone, including Hugh Hayden.
There's some irony there, there's no question about that, but you know, what our business is about and what we've always been about is using the plant to create things and to do positive things. Our focus has been biopharmaceuticals and using the plant to yield those kinds of proteins, and works really well for that.
Biopharmaceuticals, plants that one day could be used routinely to wipe out infectious diseases. For the PBS NewsHour, I'm Mary Jo Brooks in Owensboro, Kentucky.